Swayam Prabha. Digital India. Educated India.
Now, let us take another problem and see how to find out the solution of this problem. Let us have a look at this problem. The del 2u del t square equals c square del 2u del x square, where x varies from minus infinity to infinity, with the conditions given as u x 0 equals f x, u t x 0 equals 0 and u x both approaches 0 as x approaches plus minus infinity. The first part will be similar, obviously, since x it is told that x varies from minus infinity to infinity. So, we can take Fourier transform with respect to x only, because about t nothing has been told over here. So, we are taking Fourier transform with respect to x. Now, the form will be similar. So, I will skip certain parts. Its solution process is little difficult. Minus infinity to infinity del 2 u del t square into e power I alpha x dx. This is equal c square into 1 by root 2 pi minus infinity to infinity del 2 u del x square into e power I alpha x into dx. And the left hand side obviously will be d square u bar dt square, where u bar is nothing but the Fourier transform of u. Please note this one, u bar is the Fourier transform of u, and the right side, if you break it, if you use the conditions given to us, you will obtain minus c square alpha square into u bar alpha t, u bar alpha t. This I have not written because you can check it of your own using the earlier problems. In the same fashion, if you proceed, you will obtain this equals minus c square alpha square into u bar alpha t. So, that your given ODE will be d square u bar dt square plus c square alpha square u bar, this is equals to 0. And its solution you can write down u bar alpha t is nothing but a cos of c alpha t plus b sin of c alpha t, where a and b are the constants. So, now in this case you see the difference. In this case, the given PD is transformed into second order ODE, not first order ODE. In the earlier problems, whatever we were doing, on those problems, the given PD was transformed in the first order ODE, but here it is being transformed into second order ODE. Therefore, it always depends on the problem, which kind of problem you has been given, then accordingly it will be transformed into first order ODE, or it will be transformed into the second order ODE. Now, from here your job is first to find out the values of the constants a and b. You know d from here, d u bar dt, this I can find out, d u bar dt will be minus a into c alpha into sin of c alpha t plus b into c alpha into cos of c alpha t. So, I have these two equations 1 and 2. Now, we have one thing, we know that del u del t equals 0 at x equals 0. Sorry, del u del t equals 0 at, it has been given as at t equals 0. It is given to us. So, what I can write down 1 by root 2 pi minus infinity to infinity del u del t into e power I alpha x dx. this is equals, since del t is there, but you are integrating with respect to x. So, this del t can be we can bring it outside. So, d dt of 1 by root over 2 pi minus infinity to infinity u into e power I alpha x dx you can write down, and this is nothing but u bar, because 1 by root 2 pi minus infinity to infinity u e power I alpha x, this is u bar. So, this becomes d u bar dt. So, from here using this I can say that d u bar dt equals 0 at t equals 0. From this condition, since del u del t is equals to 0. So, I am taking basically the Fourier transform on both sides, and by taking the Fourier transform on both sides, I am getting d u bar dt equals 0. So, once I am getting d u bar dt at t equals 0, from 2 now, if you substitute this in 2, then d u bar dt equals 0 at t equals 0. You will obtain basically 0 equals your t 0 means this sign term will vanish. So, 0 will be b c alpha cannot be 0, therefore, you are obtaining b equals 0. So, one value of the constant you got b equals 0. So, you see directly the condition was not there. You have been provided only with u bar equals this, which is the given condition 1. From here I am finding d u bar dt, and then I am taking del u del t equals 0 is known to me at t equals 0. I am taking the Fourier transform, and from there I am telling d u bar dt equals 0 at t equals 0. And then I am using the condition in 2 and I am finding that b equals 0. My next part is I have to find the value of a. Again, at t equals 0, u is equals to f x. So, at t equals 0, u bar alpha 0, this is equals 1 by root 2 pi minus infinity to infinity. From the definition, you can write down u x 0 into e power I alpha x into dx. And this is equals, this is 1 by root 2 pi, u x 0 is nothing but f x. So, this equals 1 by root 2 pi minus infinity to infinity f x into e power I alpha x into dx. And this I can write down capital F of alpha, because 1 by root 2 pi minus infinity to infinity f x e power I alpha x dx is the Fourier transform of f x. So, what I am getting at t equals 0, u bar alpha 0 equals f alpha. So, now from 1 if you substitute this from equation 1, if I say that t equals 0, at t equals 0 u bar alpha 0 equals f of alpha, then I will obtain a equals f of alpha. So, that once I obtain the value of a and value of b is 0, u bar alpha t, this is equals f of alpha into cos of c alpha t you can obtain. So, that you from here u x t, this you can write down 1 by root 2 pi minus infinity to infinity using the inversion formula cos of c alpha t into e power minus I alpha x into d alpha. Now, I have to evaluate this integral. What I will do at first, this cos function I can break it, this f alpha I can write in terms of the Fourier function. So, I can write down u x t equals 1 by root 2 pi is coming here, first minus infinity to infinity, then again capital F alpha is there, capital F alpha you can write down minus infinity to infinity f u into e power I alpha u du, you can write down this thing. because this actually capital F alpha you are replacing, and this cos term you can write down e power I c alpha t plus e power minus I c alpha t, cos of c alpha t we are writing like this into e power minus I alpha x into d alpha. Once I am getting this, I can, if I put alpha equals minus s, say now, I am putting alpha equals minus s and I am breaking it into two integrals. So, by doing that way, I can write down u x t equals half will come here, 1 by root 2 pi, 1 I am bringing inside, minus infinity to infinity into 1 by root 2 pi, 1 by root 2 pi into minus infinity to infinity f u into e power minus I s u, because alpha equals minus s I am substituting d u into these two terms, that is e power this into this is there, and e power this means it will be e power minus I c s t plus e power I c s t into e power I s x into d s, d alpha will become d s. So, I am getting this. Once I am getting this, now from here I can write two terms, and these two terms let me write in the next page, because the terms will be bigger one, half into 1 by root over 2 pi minus infinity to infinity f u into e power minus I s u into 1 by root over 2 pi minus infinity to infinity e power, one term will be I s into x minus c t will come into d s, and then d u will come, plus 1 by root 2 pi into minus infinity to infinity f u e power minus I s u. This term will remain same, only e power term will be changing, e power I s into x plus c t will come, because from the earlier one you can check, just by combining I can obtain these two terms into d s into d u. And this equals, I can write down from the Fourier integral formula, because already Fourier integral formula we did earlier. Please go through the Fourier integral formula, and from there you can check that this value will be, one term will be f of x plus c t, and the other term will be function of x minus c t. So, basically u x t you are getting in terms of function of x plus c t and function of x minus c t. So, once the function f x is known to me, u x we can tell that the value of the u x you can tell this thing. This solution actually we call it as D'Alembert's solution, D'Alembert's solution of wave equation, because the equation which we solved, that is D'Alembert's solution of wave equation. This type of solution, half of x plus c t plus half of f of x plus c t plus f x minus c t is known as D'Alembert's solution of wave equation. Therefore, for the wave equation, if I have the equation of that type, u x t will be becoming half into this thing, and this we have written, I am not showing you due to the time constraint. This I can obtain using the Fourier integral formula. Similar type of one more problem we will do. You see this problem. Now, we want to take del 2 u del t square equals c square into del 2u del x square, x lies between 0 to infinity, with u 0 t 0, u x 0 here is f x, and u t x 0 we are considering here as g x, and u and del x are approaching 0 as x approaches infinity. So, once I am doing it, I have to use Fourier sine transform, I am saying. So, from the criteria, from the conditions, it is obvious, quite obvious that I have to use the Fourier sine transform with respect to the function x only, because u and del x both are approaching 0 as x approaches infinity. But here also we have taken similar function. The equation is same, only thing the earlier problem we solved it using the Fourier transform, and this one we are trying to solve it using the Fourier sine transform, and the extra condition we have taken u t x 0 equals g x we have taken. So, let us see how the solution process changes for this change in the conditions. So, you apply Fourier sine transform with respect to this x. If we apply Fourier sine transform, you will obtain 0 to infinity del 2 u del t square sine of alpha x dx. This is equal c square root over 2 by pi 0 to infinity del square u del x square into sine of alpha x dx. Directly I am writing, left hand side will become d 2 u bar s. I am not explaining this because already we have done this thing, and this will be c square plus alpha square u bar s. Using the conditions provided, you please check it that if I evaluate the integral, ultimately this will be transformed to this second order ODE. So, that the value of this is u bar s is a cos of u bar s, this is equals to a cos of c alpha t, just like the earlier problem, plus b sine of c alpha t. Now, I have to find out the values of a and b now. So, at t equals 0, let me go to the next page. At t equals 0, your u bar s, if you see, this is equals to a. Your u bar s equals a. Let us see what happens at t equals 0. What is your u bar s from definition? U bar s you can write down 0 to infinity u x 0 into sine of alpha x dx, and this is this root over 2 by pi, just I have omitted because again I will use this. So, 0 to infinity u x 0 is f x into sine of alpha x dx, and this equals, you can write down your f alpha. So, effectively your A is capital F of alpha, where f of alpha is the Fourier transform, Fourier sine transform of f x we are writing. So, please note root over 2 by pi we have omitted because this again I am writing as f alpha. Also, del u bar s del t, this you can write down minus a into c alpha from the earlier condition, sine of c alpha t plus b c alpha into cos of c alpha t. So, once I am getting del u bar this. So, from here at t equals 0, what is your del u bar s del t? Del u bar s del t will be equals to, your sine term will be vanishing, that is b into c alpha. And also I have to find out that at t equals 0, what happens here? What is del u bar s del t? This is equals to 0 to infinity u x 0 into this will be del, sorry, not del square, del u bar s del t. This will be equals to 0 to infinity, since u bar s is there, this is del u bar, therefore, it will be u t x 0. Please note this one, because this is del u del t basically, del u del t into sine of alpha x dx. And you know the u t x 0 or del u del t value at t equals 0 is g t, g x. So, that this equals, you can write down g x into sine of alpha x into dx. So, this is nothing but I can denote it as g alpha, where g alpha is the Fourier sine transform of g x. So, please note that del t of u bar s is 0 to infinity, the function is u t, because for u t only the Fourier transform is this one. So, value of u t is g x, so that you can obtain g of alpha, capital G of alpha, where capital G of alpha is nothing but the Fourier sine transform of g x. And once I have obtained this, so this is nothing but b will be equals to g alpha by g of alpha by c alpha, and a already we have obtained as a alpha. So, what you are getting? Your a as f of alpha and your b is equals to g of alpha by c alpha. So, u bar s you can write down as f alpha cos of c alpha t plus g alpha by c alpha into sine of c alpha t. And once I have written this, you can write down your f x, sorry, u x t using inversion root over 2 by pi 0 to infinity u bar s alpha t into sine of alpha x into d alpha. So, this equals, if you substitute the value of this integral u bar s alpha t as this, you will obtain f alpha into cos of c alpha t into sin alpha x plus g alpha by c alpha into sin c alpha t into sin alpha x into d alpha. So, once you have the cos c cos d and sin c sin d, so these two I can break it, and using trigonometry, then u x t you can write down u x t equals root over 1 by root over 2 pi will be there, because 2 will be coming out here, 1 0 to infinity f alpha, capital F alpha into sin alpha into x plus c t plus sin alpha into x minus c t will come, and this into d alpha plus 1 by root 2 pi 0 to infinity g alpha by c alpha into this sin c sin d also will be written in the same fashion, cos alpha into x minus c t plus, sorry, this will be minus cos alpha into x plus c t into d alpha. Now, you know that what is your f x? F x is nothing but root over 2 by pi 0 to infinity f of alpha sin of alpha x dx. We know it, where capital F alpha is the Fourier transform of f x. Since capital F alpha is the Fourier transform of Fourier sine transform of f x, so I can write down f x as this thing. So, once I have written f x as this, what is your f of x plus c t? F of x plus c t you can write down root over 2 by pi 0 to infinity f alpha into sine of alpha into x plus c t into dx. D alpha, sorry, f x will be, since you are taking inversion, it will be d alpha. So, now this term you see 0 to infinity f alpha into sin alpha this. So, effectively this integral is nothing but f of x plus c t, and the other integral will be f of x minus c t. So, effectively by this way, this I am representing as f of x plus c t, and the other one I can make it as x minus c t. Now, let us see g u, what happens to g u. Your g u is root over 2 by pi 0 to infinity g alpha into sin of alpha u d alpha. Again from inversion I can write down, inverse Fourier sine transform I can write down. If you integrate it from x minus c t to x plus c t g u d u, you see how we are transforming it. 0 to root over 2 by pi, 0 to infinity g alpha d alpha I am writing, and x minus c t to x plus c t sin of alpha u du, this I can write down. So, this equals root over 2 by pi 0 to infinity, first integral will remain same g alpha d alpha, whereas for the second integral minus sin alpha u is there. So, cos alpha u by alpha, where the integration will be from x minus c t to x plus c t. So, if you substitute it, then you will obtain root over 2 by pi 0 to infinity into 0 to infinity your g alpha by alpha is coming here d alpha into cos of alpha into x minus c t in one case, minus cos of alpha into x plus c t, x plus c t, this is coming. So, this is your case that your g u is this one. So, from integral x minus c t to x plus c t, you are obtaining this. Therefore, this integration, this value whatever you obtained, that was in the second term of our u x t. So, second term of the u x t will be f of x minus c t to x plus c t g u d u. So, that the ultimate solution u x t will become half into f of x minus c t plus f of x plus c t, this is one part, plus 1 by 2 c into that particular equation will be changed to x minus c t to x plus c t g u d u. So, you see the advantage here, ultimately we are bringing it into a process where we can representing it as a function of f and g. So, that if I know f and g, I can tell what is be the exact value of u x t. Let us see quickly this problem. So, this was the problem. I am taking the applying Fourier sine transform with respect to x. This already we have done in other problems. So, I will obtain the second order ODE. I am writing the solution of the second order ODE, where we have two constants a and b, u bar s I am obtaining. Now, I know that at t equals 0, obviously if t is 0, in that case your a will be equals to u bar s. So, basically I have to find out at t equals 0 what is the value of u bar s. U bar s is nothing but it is the Fourier sine transform of u x 0. So, I am writing this. I have not written here root over 2 by pi, because ultimately I will put it in the same form. U x 0 is given as f x. Therefore, this I can write it that the Fourier transform of alpha, where f alpha is the Fourier sine transform of f x. Therefore, you are obtaining a equals f of alpha. Now, from that equation, that is on this equation, if I substitute, if I differentiate it, then I will obtain del u bar s del t as this, and at t equals 0, if you put here, your a term will be vanishing, sin is there. So, it will be b sin b c alpha. Now, at t equals 0, del u bar del t is how much? It is nothing but 0 to infinity u t x 0 sin alpha x, because this is the Fourier sine transform of u t x 0, and I know what is the value of u t x 0, that is g x. So, that I can write it 0 to infinity g x into sin alpha x into d x, which is nothing but again capital G of alpha, where capital G of alpha is the Fourier sine transform of g x. So, I obtained a and b in terms of Fourier sine transform of f x and Fourier sine transform of g x. So, I am writing u bar. Once I have written u bar, u x t is nothing but root over 2 by pi 0 to infinity u bar s alpha t sin alpha x dx. If you substitute the value, you will obtain this thing. Now, this cos c sin d is there, sin c sin d is there. So, I can break it into two parts like this. So, f alpha into sin of alpha x plus c t plus sin alpha x minus c t, like that way I am getting. Let us see how to find out the values of these integrations. What I am doing, I know that f x equals root over 2 by pi 0 to infinity f alpha into sin of alpha x. Therefore, f of x plus c t will be root over 2 by pi f alpha into sin of alpha plus c t, that is whatever I am getting here. And similarly, f of x minus c t also I can find out. Also, now see for g what happens. G u is root over 2 by pi 0 to infinity g alpha into sin alpha u du. From the inverse Fourier sine transform I can write down. So, that if I now both side integrate from x minus c t to x plus c t. So, after evaluation I am getting this, and you see this last term, this is nothing but the term which I obtained over here, g alpha by c alpha into cos of alpha x minus t minus cos of alpha into x plus t. So, I am getting this term. So, it is nothing but now u x t equals, we can write down half into f of x minus c t plus f of x plus c t plus 1 by 2 c will come, and x minus c t to x plus c t g u du. So, that we have represented the solution in terms of a compact function, in terms of function of f and g. So, like this way, depending upon the problem, we can find out the various solutions. So, last two problems, if you see, we have used the general functions f and g, and whenever f or g is known to me, in that case I can tell what is the exact value of u x t.